Okay, we're going to talk a little bit today about some basic things getting into electronics. You don't have to spend a whole lot of money just to get into the hobby if you want. And I'm assuming that anybody who's watching this knows a little bit about electricity and about electronics. And you're getting to the point where now you want to start dabbling, maybe working on amplifiers or radios or stereos or something, or maybe even small appliances, something like that. So one of the first things that you're going to get into, and it doesn't have to be expensive, is you have to have a meter. You have to be able to read voltages and resistances and things like that. Just as a basic test tool anytime you're testing electrical equipment. So this will probably be one of your first purchases of test equipment. Of course, you always need hand tools and things, but most people have those, and if they don't, they can be picked up pretty inexpensively. But the really big question is, what do you look for if you're going to buy a meter? And what are some of the things you're going to do with the meter? So that's what we're going to try to talk about a little bit. In front of you, I have 4 different examples, and actually you can see a 5th one back here that we'll talk about here in a little bit. But these are 4 different examples of something that you could get into entry level. Not necessarily these exact models, but these are examples of the types of models. And we'll talk about the differences. So most likely, I'm not going to tell you which one to get for your first meter, but the most practical one, in my opinion, would be a digital meter. Just because of the versatility, how much they can do, how easy they are to use, and so forth. So there are some differences in them, and we'll get into that in a little bit. The next model would be an analog meter. This is old. This is what I started out with right here. It's seen better days. I really won't use it anymore because the actual movement has gone bad in it somewhat. But this is what I started with, and it is unbelievable how many different things you can test with a good analog Volt-Ohm meter like this. Okay, this is a Radio Shack one from way back in the late 70s, early 80s when I bought it. Been with me a long time, so it's an old friend, but can't really use it too much because of the meter. But anyhow, let's talk about some of the similarities and differences. All of these meters do a similar function, and that is testing voltages and resistances. How they test them and some of the other features is where you can see the differences. So when we talk about a basic Volt-Ohm meter like this, okay, sorry about the glare, this is very basic. It tests DC voltage, it tests AC voltage, it tests ohms or resistance, and it even tests current or amps, okay? And it has a little buzzer built into it to check continuity. Continuity is just, do I have a signal through the wire? Is the wire broken or is it complete? And that's just a quick little test. Now, some of the pros of these meters is you can see them, you can watch the actual meter move. So if there's a varying voltage, or if there's a voltage that has a little bit of fluctuation to it, the dampening of that meter movement actually makes it a little easier to get a reading. If a voltage is varying, it's a lot easier to watch the needle move back and forth than it is to watch a bunch of digits jump around on a digital meter. So there are some instances where I still prefer an analog meter movement. Now, one of the downsides of this meter is if you look, I'll try to get in there close, you can see where it talks about ohms per volt, 30,000 ohms per volt, 10,000 ohms per volt, and so forth. That is one of the negative things of an original Volt-Ohm meter like this. As you're changing the scale, actual resistance that you present across the circuit that you're testing changes. So when they're talking about 30,000 ohms per volt, that means if you take the full scale of what you're reading, so let's say 100, okay, so I'm set to 100 volts full scale. That means when this needle is all the way to the end, see that number 10, you times that by 10, that means 100 volts. So if you take 100 volts times 30,000, that tells you how much resistance this meter introduces to your circuit when you're in the 100 volt scale and you put that meter across it. Okay? So that would be 3 mega ohms. Okay? Now, here's what happens when we go down. If we go down to the 1 volt scale, now you're putting a 30K resistor across anything you're testing. Now, if you're checking something with a lot of current to it, like a battery or something, that doesn't hurt anything. But when we're talking about a really tiny signal, like a radio signal, like you're poking around in a radio, that is going to throw off your radio. Anything that has impedance, like an oscillator or something, you are going to throw off that circuit. So these meters, for that purpose, are not good for that. These are better for checking power supplies and checking things like that. So enough about that, but that's one of the downsides. And the good side, like I said, is the meter movement and so forth. Now, the next meter is still today one of my favorites. You can pick these up used on eBay. If you really, really look around, 20, 30 bucks. Maybe not in this nice a shape, but one that works. This is called a VTVM, and that stands for vacuum tube voltmeter. Okay? VTVM. It's an analog meter, just like this. Okay? And it tests all the same things, volts, ohms, and so forth. You'll see many of the controls are the same. However, how it works inside is very different. Okay? This actually has a little vacuum tube circuit. And the vacuum tube is kind of like a little amplifier circuit, and it runs the meter. So the meter doesn't directly connect to the load like this does, like this one does. Okay? So basically, this has an impedance, and it doesn't change. It's very high. 30 mega ohms or something like that. Really high impedance that it presents to the circuit. So it's almost like it's not even there when you test with it. And the other thing is, these are really, really bulletproof. They're very, very tough. Because the meter and everything is electronically isolated from this. Okay, so this goes through big resistors, goes through a capacitor, goes through a vacuum tube, all kinds of things before it gets to this meter. What that means is, even if you overload the meter to a degree, okay, obviously everything has its limits, the meter might max out, but it won't hurt it. You just saturate that little tube, the little input of the tube, you saturate that little amplifier circuit, and it pegs the meter. It doesn't hurt it. So that's one good thing. Again, very high impedance, so when you're poking around in radio circuits, a lot less, it puts a lot less of a load across that circuit. It's a very high impedance input, which is very good. The vacuum tube itself, if you turn this meter on and you let it heat up and get to an ambient operating temperature, and then you calibrate everything in, there's all kinds of little adjustments and everything to zero all these out, this meter will get super accurate. So it's very accurate. You have the analog movement, which we talked about. You have very high input impedance. It runs on electricity, so there is a battery in here, but the battery is just used for a reference signal when it's in ohms mode, and that battery lasts years and years before it goes bad. So very low maintenance machine, very reliable, very tough and bulletproof, very accurate, and they can be had inexpensively. A lot of times you'll find finding a good probe for one will cost you more than buying the whole meter. And if you look around, you can find them. A lot of places, flea markets, things sell them. Even if the meter's bad, as long as the movement's good, they can be repaired. Okay? A lot of times just some cleaning inside, maybe some electrolytic capacitors, the one or two that's in there, maybe one of the tubes is bad, but nothing major. And there's a lot of information online for these. Okay, so if you're going to get into working on radios or working on tube equipment, older equipment, this might be a good thing to get, and it's inexpensive, so you can get into the hobby relatively inexpensive with this. Now, last but not least, definitely the most versatile probably of all of them is going to be the digital meter. Now this one here I'm showing you, these types here are all over the place. This is an old Radio Shack one. It's been around for a long time. But you can buy them at Harbor Freight for as little as $4 or $5. And they go all the way up in price to $600, $700, $800, or the bench models can be in the thousands of dollars. Now, what are the differences between all these? Well, that's why I have a couple of them sitting out. This would be a very basic digital multimeter. Just like the vacuum tube meter, it has really high input impedance. Okay, so it doesn't impose much of a load across whatever it is you're testing. So you got that. Look at all the different things we can test with this. So you can do volts, you can do continuity and ohms. You have a diode checker that actually tests diodes, really handy. You have milliamps, so you can check really low current, clear up to 20 amps, okay, AC and DC current. So it's a very handy meter, and even this one even has a little interface, old-fashioned, I don't know if anybody has this anymore, but you can actually connect it to a computer and send the readings to a computer. So this is a good meter for around the house. It'll do most of what most people want to do. Okay, but one of the things that you'll notice is when you're checking this, the AC voltage test works great with line voltage, like what's in your AC outlet. However, if the frequency starts changing and it goes much higher than 60 cycles, the AC meter gets inaccurate. Okay, so frequency actually will throw off the reading of these meters. That's where this kind comes in. So right here, what we have is called a true RMS meter. As you can see right here, true RMS. This one is a lower cost one, and I bought it from MCM Electronics a long time ago. But there's lots of other companies that make true RMS meters, and again, they can be had anywhere from $50 to about $100 will get you into a decent one. Okay, this one does an awful lot. When we turn it on, you can see it can check frequency, it can check voltage, it can check capacitance. It's got a capacitor tester built into it. It's got a diode check. It's got a transistor tester. It's got data hold. It's got the continuity. It's got variable range. So it's an auto range meter, meaning the ranges will switch automatically, unlike these ones where you have to change it to what range of voltage you want to measure. This one goes automatically. And you can set it to manual range if you want it to not switch around the ranges, the decimal point. Many different tests that this thing can do. Okay, it'll do the current, it'll do 20 amps. Okay, and one of the most important things is this is the first one where you start seeing this CAT. Okay, now what's CAT? Okay, that stands for category, and you see the Roman numeral 2. Category, when a meter has a category like that, a safety category, what that means is the meter has been tested and is certified safe against shorts and against electrocution, things like that. It's a safe meter up to a certain point. Okay, the higher the category number, the better quality the meter is, and the more safety features as far as short circuit protection and things like that, and arc over and things like that, that it has. So a category 2 is an entry level good meter, we would call it. If you notice, this one has no category rating whatsoever because it's a very low end meter. This would be your cheap $20 meter. Okay, this would be your $100 meter, $70 to $100 to get into something like this. Much better, much more durable, going to be safer if you're working on tube gear with high voltages and things. When you're working at the higher voltage ranges of these meters, this one's going to be a better job. If you have the extra money, get into something like that. Now, last but not least, this would be an industrial quality meter. Okay, pretty much most things with the Fluke name on it. There's several manufacturers out there that are real high quality, but this is a very high quality meter. It's a category 3, if you can see that. Some of them are even category 4. Very durable. Very, very tough. Very long life. They're sealed up, safe against oil and things like that. You can drop them, they don't break. This thing's physically much heavier than the lower end meters. It does many, many different things. It can test. And something like this is going to set you back, you know, $300, $400, $500, $600 for these kinds of meters. True RMS, just like this middle of the road one, meaning that if the frequency changes of your AC signal that you're testing, it's still going to give you the accurate RMS value of that AC voltage. It's going to tell you exactly how many volts it is, regardless of the frequency, within a range. You know, up to about, this one I think will go up to about 100 kilohertz and be accurate. So this one is not something you really need. I mean, if you're going to do this for a living and you're going to take it out in the field with you, or you're going to use it every day on the bench as a repair technician, I highly recommend a high quality meter. If you're just going to poke around, you know, on your bench in your basement and play around, it's a little bit much, and it's certainly an awful lot of money, and you can use that extra money on a lot of other things that you probably could use more importantly. So, in a nutshell, there's your different types of meters. Probably if I had to recommend one, I'd say this level of digital meter would be a good one to get into. But if you're going to be doing electronics, this definitely needs to be your first piece of test equipment. There are many others. You know, we have oscilloscopes and frequency counters and signal generators, all kind of things like that. You don't really need that to just start. There's many basic tools we can use to test things, and your mind, of course, is the best piece of test equipment there is. So that's it for this one. I'll do several other ones. We're going to talk maybe next time around. We're going to talk a little bit about some of the different kinds of homemade things, gadgets we can make up to be able to test things. Some homemade test equipment like a dim bulb tester and some things like that. So we'll get into that later, but I hope that helps you a little bit with meters and how they work. I highly recommend. There's many really good people out there on YouTube that give talks on Ohm's law and on voltage and current and on basic electronics theory. And I highly recommend, if you're not familiar with that, to familiarize yourself with that. When you're using a meter anytime, you could potentially be putting that meter across very dangerous voltages that you can get seriously injured or even killed if you don't know what you're doing. So certainly get a battery radio, a little transistor radio, and test things out. Don't be afraid to get into it. But if you're going to work with something that has mains voltages or high voltages like vacuum tubes, do some research before you do it. Work safe. Be careful. So I hope that's it. I hope this is helpful to somebody at least, and I hope it answered a few questions about meters and some of the similarities and some of the differences. All right. Have a great day. Talk to you next time.